Much easier. يلا, chemical equilibrium. Chemical equilibrium, we're still talking about chemical reactions, but you have to know that we have two types of chemical reactions, whether they are reversible or irreversible reaction. In case of combustion, let's say burning this sugar molecule, it will completely turn into water and carbon dioxide. This reaction is irreversible. خلاص, no longer, it's an irreversible, yeah. But let's say if you have a reaction of nitrogen gas plus hydrogen gas, it will make 2 moles of ammonia. Can those moles of ammonia be back to nitrogen and hydrogen? Yes. They found out they have two types, whether it's a reversible or irreversible reactions. The irreversible reaction, it's a chemical reaction that occurs in both the forward and the reverse reactions, like formation of ammonia, like the formation of sulfur trioxide. Okay? Bismillah. طيب. Decomposition is reversible, not all of them. Some of the decomposition is reversible, others are irreversible. Depends on the nature. Weak bases, very good. طيب, let's talk about sulfur dioxide. If you have sulfur dioxide and oxygen, it will make sulfur trioxide. Can you reverse this reaction? Yes, of course. As you can see, you start up with decomposition reaction. You can reverse it and have combination or synthesis reaction. Did you notice? طيب, we can go both ways, forward and reverse or backward. Okay? طيب, let's talk about those graphs. Maybe they will help you. Let's say I will start with two reactants, sulfur dioxide and oxygen, this and this. After time goes, both of those reactants combine to make sulfur trioxide. So as the time goes, I start having more and more sulfur trioxide, more products, right? But I noticed at exactly certain time, no longer sulfur dioxide and oxygen combining. So no decrease in sulfur dioxide and oxygen, no longer increase in my sulfur dioxide. This reaction reached a state we called it dynamic equilibrium. Okay? طيب, once again, I will discuss the concept of the reversible reactions. Once again, here, imagine you have sulfur dioxide and oxygen. They will start making the reaction to happen. Some of the product of sulfur trioxide is my product. Some of this product will start to be made. Once you start doing the sulfur trioxide, once the product is formed, some of those sulfur trioxide are back to be again a product. So this phenomena is very, very, very strange, and they call it dynamic equilibrium. Chemical equilibrium or dynamic equilibrium. What is this state? We have this analogy, it helps a lot. Again, imagine you have a store it's just opened. Okay, the store just opened now. If you at 0 time, all of the people is going up. I don't know, maybe the sale in the first floor. All of the people are going up, leaving the ground floor and going to the first floor. Maybe they have something like sale. Okay, so at this time 0, no products are formed, right? All of the reactant is going up to make the reaction happen. No product. But after 5 minutes, 5 people going up, another 5 people is going down. So let's say after like half time, not 5 minutes, after half time at 12 o'clock, you can say PM, some people is going up. At the same time, another 5 people is going down. So at this moment, the rate of forward reaction equals the rate of reverse reaction or backward reaction. At this time, there is no increase or decrease in people. So let's say at time 0, in the ground floor, I have, let's say, 15 people. At the product, 0, no product. So far, all of them are going up. So still no product. But at 12 o'clock, let's say 5 people are up, 10 people are down. But the idea is there are 5 people going up at the same time, another 5 people is going down. This concentration will change? Never. 10 people will always down, another 5 people is always up. Why this concentration, it's not changing? The concentration is constant. Why? Because 5 people is going out, up, another 5 people is going down. So the concentration always constant at the dynamic equilibrium. Why? Because the rate of the reaction of the forward reaction equals the rate of the reverse reaction. The rates, okay? Okay? طيب, what about the people? I mean, people down in the G floor equals people at the first floor? No, no, this is not it. In the ground floor could be 10, upstairs could be only 5. Or maybe, as I told you, people favor to go upstairs. Let's say there is sale. So let's say 2 people down in the ground floor while 13 people in the first floor. Why? Because there is sale there. But I mean the concentration, it will change. لا. Why the concentration always constant? Because 5 people is going up, another 5 people is going down. So the concentration will be always 2, 13. Okay? Again, this is at the equilibrium state. Why we call it dynamic? Because it's moving. It's moving. It's not static. Not in action. No, it is action. Okay? 5 people going up, another 5 people is going down. When I say it's static, when this escalator is not moving, the 13 people is up, not moving. The other 2 not moving. But since the escalator is moving up and down, the 2 rates are the same. So the concentrations of the product versus the reactant always the same. Okay? If 7 are going up, 3 going down, the concentration doesn't change. This is what I mean exactly. The concentration of product versus the reactant always constant value. Okay? We call this equilibrium, the relative concentrations between reactant and product, we called it equilibrium position. Remember when I say why only 2 people down while 13 people up? Maybe they favor to go upstairs. Maybe the sale, the items on sale is upstairs. So they favor to go somewhere. So I will call this position equilibrium position. They are not 50-50, no. It's 2 to 13, the ratio. So every chemical reaction has its own nature. We need to calculate the ratio between the products and the reactants. So this formula is very important. We need to measure the concentration. When I say this bracket means the concentration. The concentration of the product versus the concentration of the reactants. Okay? So if you have 2 products, so it will be multiplied together, like A plus B. It will be C plus D. Products divided by reactants. Products divided by reactants. Please don't mix them. Don't flip the equation. We call this constant equilibrium constant. It's the ratio between product concentration to reactant concentration. Always say concentration of product divided by concentration of reactants. Okay? What is this exponent? It means the coefficients. Okay? Okay, few points I would like to say. The value of equilibrium constant is constant only at specific or specified temperature. The equilibrium constant will be constant when you at specific temperature. Okay? طيب, when I will say the equilibrium constant is high, oh, this reaction is very good. You know why? When the equilibrium constant is more than 1, it means that you have high products versus the reactant. It means that your reaction proceeded forward. Okay? طيب, what if you have equilibrium constant less than 1? It means that you have low equilibrium constant. Low equilibrium constant. So, unfortunately, you have more reactants than the product. So, not a lot of product you have. So this reaction favored to go reverse. Again, remember when I told you sales is upstairs? طب imagine that people is more downstairs in the ground floor. What do you conclude? You conclude that the people love to be in the ground floor more, maybe because of sale, because new items, whatsoever. So what is the favor of the reaction? Is it forward or reverse? It's very important concept you should know, because we gonna talk about Le Chatelier principle soon. Okay, طيب, new easy terms. What is homogeneous equilibrium? What is heterogeneous equilibrium? Imagine if you have two gases in a container. Yeah, I have hydrogen gas. Second, imagine I have hydrogen gas and iodine gas. Both of them are gases. When I made the product also is gas. They will go back and forth until they reach the dynamic equilibrium. As you can see, the product is gas and the reactants are gases, which means that all of them in the same physical state. We will call this equilibrium homogeneous. But if you have a liquid and the product is a gas, they are keep going back and forth until they reach the equilibrium for sure. But it's a state between liquid and gas. So you call this heterogeneous or heterogeneous equilibrium. Okay, طيب, what are the factors affecting your equilibrium? I just mentioned they love to be in all of the reversible reactions love to be in this equilibrium state, right? They love to be in peace. طيب, the last point, we were talking about new terms. What is heterogeneous? What is homogeneous equilibrium? Homogeneous, when they have the same state of matter, gaseous state and gaseous state. But heterogeneous, if the, let's say, if the reactant in liquid state, while the product in gaseous state. So they are jumping between two states of matter, liquid and gas. That's why we called it heterogeneous, or different phases, different states of the states of matter. طيب, again, all the reactions love to be in a state of equilibrium. They love to be in their peace or balanced state. They love this balance. But what if you had something that disrupts my balance, disrupts my equilibrium? What the system will do, or what the reaction will do, subhanallah, they will do whatever they can to return or readjust to another equilibrium state. Very good. They will find a new equilibrium. Very good. They will change their equilibrium position. Which principle is this? Le Chatelier's principle. Write in the chat box if you ever heard about Le Chatelier's principle, please. I have to know, because it will make my explanation different. طيب, what are the things that affecting, or what are the stresses that push or disrupt my equilibrium position? I have three things that disrupt or ruin my equilibrium or my balancing state. First of all, change in concentration. Very good, Muhannad. Second of all, change in temperature. Third of all, change in pressure or volume. It's the same thing, okay? You will talk about pressure and you will flip it to get the volume, okay? خلاص? So we have three stresses: temperature, concentration, and the pressure. Be patient, I will explain it inshallah. Okay, Bismillah. طيب, change in concentration. What if you have carbon dioxide and H2O? Of course, they will make a reaction. So carbonic acid will be formed, H2CO3, okay? طيب, I did something. I increased the concentration of my carbon dioxide, okay? Now the reaction is reversible. They will reach the equilibrium state. Everything is perfect for them. Now they reach their peaceful, balanced state. But what I did now, I increased the amount of carbon dioxide. I increased the concentration of my reactant, okay? What I just did, I messed up with the equilibrium. I disrupted the equilibrium. What the system will do to rebalance, they will do whatever they can. Now, I will call this concentration as stress, a stressor, okay? So what you will do, very good, self-balancing. What you will do, I want you quickly to circle this side, the whole side, where you have a stress, and write the word stress in red. Just remember, there is a stress in here, there is a stress in this side, there is a stress in this side. What the system will do to relieve the stress? Again, they will do whatever they can to relieve the stress. You know what they will do? Subhanallah. They will move to forward, more forward. So the rate of the forward reaction will be more. Why? To get rid of the excess carbon dioxide. If you have excess carbon dioxide in your body, it will be suffocated. The blood will be toxicated, poisoned. So you need how to get rid of the carbon dioxide? By quickly move forward reaction, so that it will speed up the forward reaction. So all of this carbon dioxide will be carbonic acid. So now they reach the equilibrium state again. But what are the consequences of my move? I increase the carbonic acid. So again, how to solve those types of questions? First of all, what did you increase? I increased the carbon dioxide. So write the arrow up, circle the parts where there is a stress, circle it, and then what do you have to do to relieve the stress? Go oppositely. You go away from the stress, okay? So move the opposite side. Opposite side, I mean move, in this case, I mean move forward, okay? As a consequences of my moving forward, the carbonic acid or the product is increased. Am I clear? طيب, I have a different type of stress. What if I increase the carbonic acid? طبعا, it's an acid. You shouldn't have a lot of carbonic acid in your body. So let's say, what if I increase the carbonic acid? I added more and more and more carbonic acid. Okay? Where is the stress now? I want you to circle the side where you have stress and write the word stress. Now, what the system will do? Stay away from the stress. Go oppositely. So now, write in the chat box, please. Do you think the system will move forward or reverse or backwards? Yalla, write in the chat box quickly. What the system will do? Yes, very good. They will go reverse. Why? To relieve the stress. So reverse reaction will take place. I mean, the rate of reverse reaction will be higher. As a consequences, what will happen? Higher carbon dioxide and higher H2O. Subhanallah, this reaction happens in your lungs, where all of this carbonic acid will turn back to be CO2 and H2O and exhaled outside of your body. Subhanallah, subhanallah, your body is designed perfectly. So see how the change in concentration can be one of the stresses. Allah, let's talk about the second stress. What if you have higher temperature? طيب, higher temperature. Which side will be affected more? Take a look. I don't care exothermic or endothermic. Listen to me, please. I will give you an easy idea, easy way. Now, where is the word heat is written? Here or here? Yeah, it's here. If you increase the temperature, so where is the heat? Yeah, this is the place, or this is the side the stress will be. So quickly circle the part that you have a stress and write the word stress, danger. Now, what the system will do to relieve the stress? Very good. Go forward or reverse? Reverse. Why? To relieve the stress. Now, less heat, so the equation will not, the reaction will not explode, right? So the reverse reaction will be higher. They will relieve the stress. Very good. Consequently, what's increased? What is increased? Nitrogen gas more, hydrogen gas more. Unfortunately, what decreased? I have less ammonia now. So if you're trying to produce ammonia, I'm sorry, increasing the temperature will not help you. In fact, it will decrease my product. Clear? طيب, I want you to be patient and imagine if we have less temperature. What if I decreased the temperature? Be patient, please. Temperature. So which part will be affected? This side. But now I will write in front of the word heat, low. Now I am decreasing the heat. So write this arrow. The question now, where is the stress? Where is the stress? The stress is the other side. I don't have a problem if you cool down. Now the problem in the other side. So circle the other side and write the word stress. Stress. Which one will be affected? I mean, which side the reaction will go to relieve the stress? Now this side has higher energy. So you need to relieve the stress. So it will go forward reaction. So consequently, what's going to increase? أيوه, the product. So I want you to ask you a question. If you want to increase the ammonia production, give me one solution. Increase or decrease temperature?
Yes.
Increase. No, decrease the temperature. This is number one. Can you give me something else? I want to increase my ammonia production. Yalla, give me something else. It deals with the concentration. Can you increase the nitrogen or hydrogen? Yes. If I increase more of those reactants, the stress will be here. So I'm forcing the reaction to go forward. Good, because heat is technically a product. When you remove the product, reactant ramp up. Very good. Excellent. Notice, ya Walid. You deal with this heat as if it's one of the normal products. Okay? طيب, what about change in volume or pressure? Again, volume inversely proportional with the pressure. So I'm going to talk about pressure only, and you flipped it, okay? Yalla, what about changing in pressure? Please take care and open your mind. How many moles in the reactant side? Can you tell me how many moles? I have 1 plus 3. I don't care the type. Tell me how many moles in the reactant side. In the reactant side, I have 1 plus 3, so I have 4 moles. How many moles in the reactant side? Again, I don't care about the type. Tell me how many moles or how many particles colliding each other. I have only 2. So the question here, which part has more pressure? The one that 4 moles are colliding each other or 2 moles are colliding each other? It's more particles, more collisions. Yes, very good. So 4 moles has more pressure than the 2 moles. So take care, the pressure is in here. Just write the word P to remind yourself. Oopsie. Write the word oh. Don't write the word P. Write plus P, okay? Now the question is, will you increase the pressure? Yes, I need to increase the pressure. What's going to happen? Which side will be the stress? The one that I wrote P, right? So just put the arrows up, circle the part that you have a stress, and write the word stress, stress, stress. Which part, where the reaction will go? You go forward or reverse? Yes, forward. Why? To relieve the stress. As a consequently, what's gonna increase? The product or the reactant? Forward. So very good. The product will be increased. طيب, on the other hand, imagine that I decrease the pressure. Which part? I already wrote the word plus P. Remember? I already said plus P in here. Which part I will write? I will write the arrow here down, right? So where is the stress now? If you decrease the pressure, the stress will be on the other side. Write the word stress, move away from the stress to the other side. Consequently, reactants increase, product is decreased. Okay. What about catalyst? It will affect anyway the equilibrium? No. The equilibrium will never be affected by adding or not adding a catalyst. In fact, catalyst speed up the reaction only, but not increasing or decreasing. Yes, Luay, write it in the chat box, please. What was the last part? What was the last part here? Here. طيب. I was saying that what if you decrease the pressure? طيب, again, what you have the same reaction, remember? 4 moles here and 2 moles here. So I remove those two numbers and write the word P. Now where is the pressure? هنا. So write plus P. Okay? Now you need to decrease the pressure. Decrease when the pressure is reduced. Okay? So I will put the arrow down here. Now here less pressure. That makes this side the stress. So what the system will do? They will go to the reverse. Reverse. Why? To decrease. Yes, backward or reverse. So the reaction will be, so the reactants will be less. Okay, to relieve the stress, and reaction will be less. Okay. No catalyst, no effect. Yalla, questions? Again, students, please be patient. We need to start acid base today. So inshallah, we will take 15 minutes. Better, so we will not take much time tomorrow, inshallah. Yalla, when a chemical reaction can go forward and backward, this is called multiple reaction, continuous, equilibrium, or reversible. Yes, very good. Reversible reaction. It can go forward and reverse. This is reversible. When forward and backward reactions rates are equal, what is this now? In which state? It's an equilibrium reaction or equilibrium state. Very good. 2A. The value of equilibrium constant is constant. When which factor of the following is fixed? I told you, when you fix the, excellent. When you fix that, when you make the temperature constant, the equilibrium will be always the same. Specifically the temperature, okay? Temperature specific. When reactants and products are in the same physical state from gas to gas. So this is homogeneous or heterogeneous? Yes, homogeneous equilibrium. Very good. Equilibrium constant, K equilibrium. You're measuring the ratio, or you're making a comparison between what divided by what, or what to what. Remember, reactants. Oh, sorry, I did the mistake. Products versus reactants. See, I was going to say, please don't do this mistake, and I did the mistake. Product concentration divided by reactant concentration. طيب, in my case, how many product? Don't forget the exponent, okay? The product, how many products? I have only HI. How many moles of HI, hydrogen iodide? 2. So the exponent will be 2. How many reactants? I have hydrogen gas and iodine gas. How many moles? 1 and 1. So multiply, please don't add. Multiply. There are exponents, no exponents, because I have one coefficient, one as a coefficient. So what was the answer of number 5? C is perfect. Yeah, very good. Number C, very good, everyone. If reactants concentration is greater than products concentration, if the equilibrium constant, not this, here, look here. Look at the equation already written. If you have more reactants than products, so equilibrium constant is more or less than 1? Of course, not equal 1. What it will be? Not equal 1, sure. Less than 1. Very good. Less than 1. A, B, C, D. Number A. Yes, very good. Equilibrium constant will be less than 1. Good. Number 7, which does not result in a shift of equilibrium to the right. Okay, how? There is no shift to the right. Removing products, adding reactants, increasing concentration, or adding products. Basically, there are repeated answers, right? Adding reactants or increasing concentration of reactant is the same thing. Probably they will shift to the right. Okay, shift to the right. B, C, shift to the right. When I add product, I will force it to shift to the left, right? When I remove the product, it will shift to the right. So the only condition is adding product. When I add the product, it will shift my reaction to the left. Am I clear? Number 7? Yes. Adding product will force my reaction to shift to the left. But if I remove, let's say A plus B equals C. If I remove the product, the stress will be here, right? So it will shift the reaction to the right. Get it? Good. Stress is applied to a system of an equilibrium reaction. The reaction will shift to, yalla, this is Le Châtrier. If the stress is applied to a system, what the system will do, it will go to the side of less stress. Very good. The only factor that affects equilibrium constant is, number 9, temperature. Very good. At constant temperature, remember. In the following reaction, if we increase the temperature, yalla, first of all, look for the word heat. I didn't write the word heat, but I have kilojoules. So if you increase the temperature, this part will be affected. So circle it and write the word stress. What the system will do, it will go forward or reverse. Yeah, forward. So consequently, nitrogen dioxide will be more or less? Nitrogen dioxide will be more. Dinitrogen tetraoxide will be less. So question 10, the answer will be, yeah, very good. Number A is perfectly right. If forward reaction was exothermic reaction, and we decrease the overall energy surrounding the reaction. Oh, okay. Just don't confuse yourself. Exothermic reaction is written like this. A plus B equals C plus heat, right? So if you decrease the heat, so the stress will be here. What the system will do to relieve the stress? Now, is it clear? The forward reaction will increase? Yes. Consequently, the reaction will go to the right and the product will be added more. Any change in dash result in change in chemical equilibrium. We said the factor that is affecting equilibrium constant is, very good, again and again, temperature. Yes, very good. Ethylene, C2H4. Muhammad, can you write it in the chat box? Ethylene, C2H4, reacts with hydrogen to form ethane, right? This is the heat. Can you increase the amount of hydrogen? How could you increase the amount of hydrogen in a system? Let's see. If I increased the heat, the system will shift reverse, right? Very good. You answered it right. Can you explain question 9? Yes, sure. Question 9, the only fact, no, question 9, actually, it's already, we repeated it 3 times. 3 times. Let me remind you. Equilibrium constant. Where is it? The only factor that affects equilibrium constant is temperature. This is 1. Also, we wrote it here at a given temperature, the law of equilibrium at given temperature. We wrote it 3rd time at constant temperature, at specified temperature. So don't mess with the temperature while calculating the equilibrium constant, okay? Why can't you increase concentration of products to increase concentration of hydrogen? Let's see. So first of all, is it written one of the choices? لا. It wasn't one of the choices. Increase concentration of A definitely will increase the concentration of product will increase the reactant. صح. You're right, will increase the hydrogen gas. But did you see it in the choices? Tell me, Ayman. A, B, C, D. Do you see this choice? The rate of forward reaction will decrease. It's the next slide.